Hello, AP Calc students. Glad you're here. This is our next set of rules. They're called the product and quotient rules. I remember telling both classes that while the derivative of a sum of things is just a sum of the individual derivatives, the derivative of a product of things is not. There's a different rule for that, and same with quotients, and we're going to see what those are right now. They're more complicated. So a brief review of the rules so far. The derivative of a constant is 0. The derivative of a linear function is just the number times x, the number that's multiplied by x. You can think of this as like the derivative of a line is like the slope of the line, like the rate of change. The power rule is the big one we learned. This says that the derivative of a power is n x to the n minus 1. You bring the power down, subtract 1 from it. Sum and difference, that's what I just talked about. The derivative of a sum or difference is just the derivative of the individual functions, each one added or subtracted, depending on what the original problem said. You all did that a bunch of times on the notes we did in the last couple classes. And then the constant multiple rule says that the derivative of a constant times a function is the constant derivative of the function. Again, you did these a bunch of times without even thinking about doing them. So these are the very most basic derivative rules that there are. Sure, there's a lot of rules. So rule for products and quotients, damn straight. So this is what it looks like. The derivative of a product of two functions is this. And I'm going to use f prime. Maybe I'll just use the primes. I'm just going to use the prime notation for this. Let me change my mind about that. I don't know why this thing is so wiggly right now, but it is. So if I have f times g prime, derivative of this product is this. It's f prime g plus g prime f. This is how I remember it. You could write it as fg prime. The order here doesn't really matter. In either of these, because a product, you could switch it. You could write gf prime because multiplication is commutative. And you could also change the order of these because addition is commutative. But basically, the derivative of one times the other plus the derivative of the other times the one. So the first derivative of the first times the second plus the derivative of the second times the first. There's like lots of like little tricky mnemonic devices for remembering this, but this is the basic rule. And this is one where you could multiply this in and then just do the derivative of the powers, but I want to do it this way just to show you guys that this is a thing that can be done. So if this is f of x, f prime of x is, so think about this, there's two functions here multiplied. There's the blue one and the red one. These things are multiplied together. So the product rule says the derivative of a product is the derivative of the first thing times the second one. The first thing is x squared. The second thing is negative 3x squared minus 2. So f prime g, the derivative of the first times the second. The derivative of the first is 2x. The second is negative 3x squared minus 2. So this is f prime times g. And then plus, there's a plus here. That's going to become important when we talk about the quotient rule in a minute. The derivative of the second times the first, g prime times f. So the derivative of this second one times the first one. The derivative of the second one is negative 6x plus the 0 for the negative 2. And then the first is x squared, like that. And you could simplify. 2x times negative 3x squared is negative 6x cubed. This is going to give me negative 6x cubed again. Negative 6x cubed from that, and then 2x times negative 2 is negative 4x. So the grand total here is negative 12x cubed minus 4x. And I promise that if you multiply this out and take the derivative like we did before, you get the same answer. You might be thinking, well, why would I ever do it this way if I could just multiply them out and get the same answer? And it's because you can't always multiply it out. And sometimes it's much more difficult to multiply it out than it is to do it this way. This is actually going to be a shortcut, I promise. But this is the product rule. It says the derivative of a product of functions is the derivative of the first times the second plus the derivative of the second times the first. F prime G plus G prime F. That's how I always remember it. If you want to pick your own way to remember this formula, feel free to do so. Not much to it though. So here's another one. Product of functions here. And if you multiply this in here, you don't just get powers of x, so it's like not as convenient. If I was thinking about this as a product, I would, in the context of the rule, I would call this first thing f, and I would call this thing g. F is the first, is e to the x, and g is x plus x cubed. So the derivative of f is the derivative of the first. Remember, the derivative of e to the x is just e to the x again, times the second, plus the derivative of the second. Well, that's 1 plus 3x squared times the first thing. And you can multiply all this out and get a bunch of like random things with x's and e to the x's in them, but let's not do that. Let's just leave it like that for now. Point here is to understand what the rule says. Here's another one. And this one again would be kind of a pain to multiply it out. So I'm just going to use the product rule again. F prime of x equals, so the derivative of the first, which is, the derivative of that is just 0. And this gives me negative 3 x to the negative 4 using the power rule, times the second, negative 4x cubed plus 3. Remember, this one I don't have the derivative of yet. And then plus the derivative of the second now times the first. Derivative of this is negative 12x squared, and that's 0. So I just don't put anything, and then times the first thing just as is. Negative 3 plus x to the negative 3. And then again, you can multiply all this out, but let's not. And again, I could give you a million examples of this, but I think maybe you get the picture. Power rule, derivative of the first times the second plus the derivative of the second times the first. This is like a more of an AP kind of a question because there's less actual taking of derivatives and more do you understand what the rule is happening here. So maybe it's a good idea, so let's find f prime of 10, to think if this is f of x, it might be good to write f prime of x out first. So f of x is g of x times h of x. This is a product. I'm going to have to use the product rule. I'm going to do the derivative of the first, which is g prime of x, I don't know what it is, times the second, plus the derivative of the second thing, which is h prime of x, times the first. This is like just a straight example of the product rule. I haven't done any like actual math here yet in the sense of like taking derivatives. Though in the most basic sense, this is all math is doing this. Then it says find f prime when x is 10. So f prime of 10, I just put a 10 for every x. It's g prime of 10 times h of 10. Again, just replacing the x's with 10s. Plus h prime of 10 times g of 10. And the convenient thing is they told me what all these values are in a problem up here. Right, all of this stuff. That's what this is all about. So g prime of 10 is 0. Well, that's convenient. I actually don't care what h of 10 is now, but I'm going to write it anyways. H of 10 is 560. Plus h prime of 10, which is 35. And then g of 10, which is negative 4. This conveniently goes away because it's 0 times a number. 4 times 35 is 140, so I get negative 140, and that's the answer. So, like I said, this is more conceptual. Like we didn't use any rules. We didn't use any power rules, like there's no like e to the x's in it here, but you use the product rule, and if you use it appropriately, you get the right answer. And that's basically what I would like to know if you know how to do. I'm going to give you some like this to make sure you know how to use a power rule and stuff, but I'm also going to give you ones where it's conceptual and you just have to like know what the rules are. All right, I'm going to break this video here because we're halfway through, and then I'll keep it up here in just a minute. So, to be continued.